Hello students, welcome back to Vast Diversity. Today we're going to be continuing with modeling with linear equations, quadratic equations, and other type of equations. Let's remember what is a linear equation. So a linear equation is in one variable x. It's an equation that can be written in the standard form. Ax plus b is equal to 0. Right, but we can also say this is the equation, but we can also say when we want to graph an equation, we can say y is equal to mx plus b. Right? This is also a linear equation, just as a graph. So here, a and b, m and b, are real numbers with a and m not equal to 0. Okay, right? And so in order, if we want to find the solution to the linear equation, we are going to go ahead and equate this equation, and essentially this equation, to 0. Okay, now how can we solve for such equations? And in order for us to solve it, we can use the generating equivalence equation. That's how we call it in mathematics. So essentially, what we can do, we can perform algebraic operations in order for us to isolate the variable that we are looking for, right? So in our case, we will be always looking for x. Okay, so what would be the steps we can take? So here's a few examples. So an equation can be transformed into equivalent equation by one or more of the following steps, right? So for number one, we can remove the symbols of grouping. So we can group the equation. Right, so for example, we have 2x minus x. Right here, we are thinking of imaginary 1 times x. So 2x minus 1x is going to be just 1x. 1x is equal to 4. So we know that anything times 1 will be anything. So 1 times x is just x is equal to 4. Right, so essentially, we're transforming it into that kind of equation. Okay, now we can also add or subtract the same quantity to or form each other side. Right, so what are we doing here? Right, we have x plus 1 is equal to 6. So, okay, we can go ahead and subtract 1 from both sides. So we're going to have x plus 1 minus 1, so it's going to be x plus 0, which is x, is equal to 6 minus 1, which is 5. Right, which is exactly the same thing we have here. Okay, and now we can multiply or divide each side of the equation by the same non-zero quantity. So as long as x does not have a 0 in front of it, we can say, well, let's go ahead and divide by 2. Both sides, so 2 and 2 becomes 1. So 1 times x is, once again, x is equal to 6 divided by 2, that's 3. That's exactly what we have here. And then we can interchange the two sides of the equation. So 2 equal to x is the same thing as x equal to 2. Right, and we can keep that in mind. So let's take a look at a few of the examples that we can do to solve for x. Right, so example 1, let's say we have 3x minus 6 is equal to 2, right? Or let's go ahead and say, okay, if first what do we have to do? We can divide by 3 if we want to, but let's go ahead and add 6 first to both sides, because we're going to be dividing at the very end, because here we have a multiplication of x, so we have to divide on the other side. So we're going to have first plus 6 to both sides. So negative 6 and positive 6 cancel out, so we have 3x is equal to 2 plus 6, that is 8. Okay, so we have 3 multiplied by x, so let's go ahead and divide by 3 both sides. So 3 and 3 cancel out. They are essentially becoming 1, so 1 times x is just x is equal to 8 divided by 3, it's going to be 8/3, right? It's going to be a fraction. Okay, perfect. And now let's take a look at another example. Example 2. We will have 5x plus 4 is equal to 3x minus 8. Okay, so our main goal here is to move x to one side and all of the other numbers to the other side. So regularly in mathematics, we choose to deal with the left side. So we're going to be moving the variables to the left side and all of the numbers to the right side. So let's go ahead and subtract 3x from both sides. Right, if we do so, 5x minus 3x, it's 5 minus 3, which is 2x. Plus 4 is equal to 3x minus 3x, that's 0. 0 minus 8 becomes negative 8. Okay, so now let's go ahead and subtract 4 from both sides. We will have the following. We will have 2x, positive 4 minus 4, that's 0, so it's just 2x plus 0, which is 2x, is equal to negative 8 minus 4. So minus 8 minus 4, that's going to be negative 12. Okay, and now let's go ahead and divide both sides by 2. So we're going to have x equal to negative 12 divided by 2, that is negative 6. So our answer for this example would be negative 6. Okay, perfect. And so essentially what we were doing right now is we were solving a linear equation, and we were finding the x value for the linear equation. And what we can also do, we can also use the same methodics for rational equations. Right, let's take a look at one more example, which is going to be a rational equation. So it's going to be example number 3, and we will have as following. We will have x over 3 plus 3x over 4 is equal to 2. Okay, so here we can do multiple things. We can factor out x and then add the fractions, or we can also find the lowest common denominator, right? So let's find lowest common denominator, LCD, which is going to be, so it's a multiplication of all of the denominators that we have in this equation. So in this case, it's 3 times 4, and here 2 has a 1, so we're not considering it. So 3 times 4 is equal to 12. Okay, perfect. So now let's go ahead and multiply the entire equation by 12. And how would we do that? Is as following. So x over 3 plus 3x over 4 is equal to 2. And we are multiplying the entire equation by 12. So we are go ahead and distributing it to every single term that is separated by the addition or subtraction, right? So we're going to have x over 3 plus 3x over 4 is equal to 2, and then we're going to have, so 12 times x over 3 plus 12 times 3x over 4 is equal to 12 times 2. Perfect. So now we can simplify. We know that 12 divided by 3, that's going to be 4x, plus 12 times 3, that's 56, divided by 4, that is 9x, is equal to 12 times 2, that is 24. Okay, now we can combine like terms. So we have 4x plus 9x, which will become 13x, which is going to be equal to 24. So now what are we going to do? We're going to go ahead and divide by 13 on both sides, and we will have that x is equal to 24 over 13. Perfect. And that's going to be our answer. Okay. So we can also do that for the linear equations with rational terms. So you can do that example on your own. And now let's go ahead and move on to a little bit of graphing. And remember how we can do graphing. So for graphing, we also need to find intercepts, right? In order for us to find the solutions and the b value for the mx plus b, we need to find intercepts. So in order for us to find intercepts, let's go ahead and take a look at this. So a good reminder. In order for us to find intercepts, so to find x-intercept, right, when we're intersecting the x-axis, and let me remind you how that looks like. So if we have x and y, okay, so when we want to intersect the x-axis, we have to set the y as an equation to 0 and solve the equation for x value. So for number 1, essentially, if we have y is equal to mx plus b, we have to make sure we're solving mx plus b is equal to 0, right? And then we can solve for x. Then number 2, in order for us to find the y-intercept, so we're intersecting the y-axis, we have to set x to be equal to 0 and solve for y. So for number 2, if we have y equal to mx plus b, we have to say, so in the first one, we said that y is equal to 0. In the second one, we're saying that x is equal to 0. So it becomes m times 0 plus b, which is equal to y. Right, in this case, in this kind of equations, we know that y will be always equal to b. Right, for the linear equation, the b coefficient is the y-intercept. Meanwhile, it is useful to keep in mind because this rules will apply to all of the equations. All of the equations when we are trying to find the x-intercept and y-intercept. And for x-intercept is more of a bigger problem because the more complicated the x values are, the more difficult it is to solve a problem and find the x value. So we will see that once we move on to the equations of quadratic and cubic polynomials or a circle. Okay, so now let's go ahead and take a look at one of the examples. So one of the applications of how can we actually apply a number line, and a linear equations. So here is a problem from the book, actually. So the number y in thousands of females participant in high school soccer in the United States from 2008 through 2019 can be approximated by the following linear model. Y is equal to 4.473 t plus 355.675, where t is between -2 to 9, where t represents the year with t equal to 0 corresponding to 2010. So part A, we want to find algebraically an intercept y of the graph of the linear model shown in the figure. And let me go ahead and demonstrate that figure right over here. All right, perfect. So here is the following graph. Perfect. Right, of a linear equation. And part B is according to that model, in which year did participation reach 387,000? Okay, perfect. So keep in mind that y is in thousands, so that's why there is no thousands in it. Okay, so let's go ahead and start with part A. Right, so in order for us to find y-intercept, right, by our rules, we want to say, okay, well, y must be equal to, y-intercept, t must be equal to 0, t must be equal to 0. So, and then we have to solve for y. All right, let's go ahead and take a look at it. So we will have y is equal to 4.473 times t plus 355.675. So t is equal to 0, so we're going to have 4.4730 times 0 plus 355.675. So anything times 0 is 0, so we will just have y to be equal to 355.675 thousands. Okay, right. So our y-intercept is 0, 355.675. And if we take a closer look onto the graph, it's right here, right? It's that point, and we know that, right? We know that. We can see it, but now we know exact value of it. Okay, so this means, what does that mean? This means that at year 2010, right? Because t0 corresponds to 2010, so during 2010, we had 355,675 female participants in high school soccer in the United States. Okay, now for part B, according to this linear model, in which year did participation reach 387,000? Okay, so here it's in thousands, so we have to keep in mind we have to simplify. So 387,000. If we divide by 1,000, we're gonna have 387, right? Because our y is in thousands, we have to scale it. Okay, so we have to make sure that that's our y value. And we're going to go ahead and plug that in. So we're going to have 387 is equal to 4.4730 times t plus 355.675. Okay, now we have to solve for t. How do we do that? So the first thing is we're going to subtract 355.675 from both sides. And now, after we do that, so 387 minus 355.675, we're going to get 31.325 is equal to 4.4730 times t. The next thing is we're going to go ahead and divide both sides by 4.4730. We're going to simplify and give us the t value. So then t is equal to, so 31.3275 divided by 4.473 is about, I'm going to say about, this means approximately 7, right? So essentially, since T0 represents 2010, T7 is representing 2017, right? So in 2017, we had approximately that time, we had 387,000 female participants in a high school soccer, right? Okay, perfect. So that would be it for this problem and this application. Now, let's go ahead and think about mathematical modeling, right? So that leads us to a general, very big mathematical field of modeling. So essentially, the way modeling works is, first, we are stating a verbal description of a problem, right? And then we think about verbally about a model, of what kind of model can be used, what mathematics we can use to actually make a model, and then we're going to assign labels such as X label, Y label, and then we're going to come up with algebraic equation, right? So what would be an example of such? So let's go ahead and take a look at this example. So we have that you accept a job with an annual income of $32,300. This includes your salary and a year-end bonus of $500. You're paid twice a month. What is your gross pay before taxes, for each paycheck? Okay, so verbally. Okay, let's come up with an equation. So verbally we have annual income. Annual income, okay, so that's our Y variable, right? Annual income. That's going to be our Y. Okay, our salary, so our end year bonus, so at the end of the year, right, we get $500. So that's, I'm going to call it constant B. And then we also know that we are getting paid twice a month, right? Paid twice a month. So what does that mean? In a year, right, depends on how many years we would have the following. So it would be 24 times we're getting paid a year, right? Because a year has 12 months. 12 times 2, that's 24. And depending how many years we work, so let's say we say, well, 24 times X, that's X is amount of years. So Y, annual income, X, number of years. All right, so essentially, what kind of equation can we write? We can write, first we can think about a model, a verbal model, right? So by using our thought process, we can come up with the following equation. It's going to be the verbal model. Annual income is equal to 24 paychecks times the amount of each paycheck plus the bonus. Okay, and then, well, since we can now go ahead and label, right? Label everything, we can say the following. We can say that our annual income, which is given by the problem, is $52,300, right? And everything here is in dollars. So amount of each paycheck is X. Bonus is $500, right? Amount of paycheck. And then bonus is, so this is the amount of each paycheck. So how many paychecks we get, right? And then bonus is in dollars. So this here is a number. So we know that how much we actually get per paycheck here. And so, okay, let's go ahead and set up the equation. So we're going to have 52,300 is equal to 24 times X plus 500. So in order for us to solve it, let's go ahead and subtract 500 from both sides. So we're going to get the following. We're going to get that negative 500. And then, so positive 500 minus 500, that is 0. So we will have 31,800 is equal to 24 times X. And then we're going to go ahead and divide both sides by 24. To make sure we isolate X, and let's flip it. So we're going to have X is equal to 31,800 divided by 24 will give us $1,325 before taxes. Right? Perfect. So that's how we would use first verbal modeling. Then we would describe each term that we need to use, and then we would transfer it into the equation. Okay, and some of the key words when we are actually translating the equations, because most of the problems are difficult, not because of the math is difficult, but because of the verbal translation to the mathematics might be difficult. So some of the key things that we need to keep in mind is as following. So the keywords for addition means sum plus, increased by, more than, and total of. So we're looking at the sum of 5 and x. So it's 5 plus 6 or x plus 5. 7 more than y, so 7 plus y or y plus 7. Subtraction, right, would be the words such as difference, minus, less than, decreased by, subtracted from, reduced by. So the difference of 4 and b means that it's 4 minus b. 3 less than z, so z minus 3. Then product and multiplication in general. So as I said, product multiplied by twice times percent of. So here 2 times 3, that's 2x. But 3% of t is the same thing as 0.03, but that's essentially the same thing percentage-wise. We still haven't talked about it, but percentage is 3 over 100, right? We're always talking about out of 100%. So 3 over 100 t. Then division. So when we're dividing, we're talking about quotient. Quotient is a popular word in mathematics. And ratio as well. And as well, we have divided by and pair. So ratio of x to 8, which is x over 8. And then the last part is equality, which is equals to, is, are, was, will be, represents. The sales price S is $10 less than the list price L. So what does that mean? That means S is equal to L minus 10. Okay, perfect. So those things are definitely going to keep in mind when solving and modeling problems, because they usually are the tricky ones. All right, perfect. Now we will go ahead and move on to some of the quadratic equations. We kind of touched on them last time, but now we're going to dive in more. So quadratic equations are as follows. So quadratic equations. Okay. So quadratic equations have a square as a variable of them. So we're going to have y is equal to a times x squared plus b times x plus c. And that's going to be equal to our quadratic equation because we have x squared. Okay. And then when we want to solve for quadratic equation, we use the rules that we learned, that if we want to find the x-intercept, is going to be y equal to 0. If we want to find the y-intercept, x is going to be equal to 0. But as you notice, if x is equal to 0, the y-intercept is always the constant, which does not have any variable attached to it. Okay, but how can we solve a quadratic equation? There are multiple ways. We can always simplify an equation by factoring out the quadratic equation. So as an example, right, let's take a look at our first example here. So example, say 2.1. Okay, so here we're going to have 2x squared plus 9x plus 7 is equal to 3. Okay, so the first thing we're going to do is we're going to go ahead and subtract 3 from both sides. So we're going to have that 2x squared plus 9x plus 4, right? 7 minus 3 is 4 is equal to 0. Okay, so now we are in a standard form in order to solve the equation. But let's recall a few lessons ago we learned about a cross method for the quadratic equations. Okay, so now let's go ahead and actually do that. So we know we have an equation. So we know if we add something, we're going to get a 9. If we multiply something, we're going to get an 8. So we got to have two variables essentially that can do that for us. So something plus something will give us a 9, and then something times something will give us an 8. Okay, so let's think about it. So it's going to be 8 and 1. So, or 1 and 8. 1 and 8. Okay, so let's go ahead and rewrite it as 2x squared plus 8x plus x plus 4. And now we're going to be factoring out by grouping. So here we can say, well, this is our first group right here. And here's our second group. So we're going to have 2x as our common variable between these two terms, x plus 4 plus 1 times x plus 4 equal to 0. So we have two multipliers. 2x plus 1 times x plus 4 is equal to 0. All right. So that means since we're multiplying two parentheses, we're multiplying two terms. So when we multiply two terms and they are equal to 0, that means that one of the terms must be 0. So we have either 2x plus 1 equal to 0 or x plus 4 is equal to 0. Quadratic equation means that we will have two solutions, right? It does not guarantee that we will have two real solutions, but it is essentially has two solutions, right? And if we consider both, if we consider all of the numbers that we can think of, including complex numbers, then we will always have solutions. But in this case, we are considering that x is a real number. So let's go ahead and solve for x. So for the first x, right, I'm going to call it x1 here, and I'm going to call it x2 right here, because we essentially get two solutions, because once again, equation is quadratic. So let's go ahead and subtract 1 from both sides. And we will have that 2x is equal to -1, because 0 minus 1 is -1. And then we're going to go ahead and divide by 2, both sides. So 2 and 2 cancel out, and we have that x is equal to -1/2. Okay, and for the second equation, let's go ahead and subtract 4 from both sides. So we will have that x is equal to -4. Okay, and now so our x1 is -1/2, our x2 is -4. So we have two solutions for this equation. Okay, perfect. And another way of solving it is by factoring, right? Is by factoring, because sometimes we will have an equation as following. So example 2.2, which will be, so let's say x squared is equal to some constant d, right? And we are assuming that d is greater than 0, right? Because if it's equal to 0, then x is 0, and if it's less than 0, we're going to be entering complex numbers, which is not yet quite our interest. So let's say that d is greater than 0, right? It's a positive number. So then we will have, if we subtract d from both sides, right, what are we going to get? We're going to get x squared minus d is equal to 0. So let's try to factor this out. A couple lessons ago, we talked about factoring out irrational numbers. So that's what we're going to do. We have a square here, so we're going to have x plus square root of d times x minus square root of d. Right, that's how we can factor it out, and is equal to 0. So we have two multipliers, and that means that if we are multiplied and the result of product is 0, that means one of the parentheses must be 0. So once again, we have two cases. Case number 1 is x plus square root of d is equal to 0, or x minus square root of d is equal to 0. So, and once again, it's going to be x1, and this is going to be x2. So for the first case, let's go ahead and add square root of d to both sides. We will have that x1 is equal to square root of d. Perfect. And then for the second case, so x2 minus square root of d, we're going to go ahead and add square root of d to both sides. And we will have that x is equal to square root of d. Okay, once again, we have the two solutions. And this is important because every time we're taking a square root, we essentially have two solutions, because either a positive number or negative number can still be equated to the square of the number. Right, and here's the rule, right, essentially to remember it. So u to the power of 2 is equal to d, where d is greater than 0, has exactly two solutions, the positive square root and the negative square root. And that is important to keep in mind, especially for algebra. All right, so we also call it a principal root. Okay, now since we know about principal roots and everything, we can talk about completing the square. So we can also have a complete square when we are solving a quadratic equation, because sometimes it's easier to complete the square and then solve the equation rather than trying to solve infactorable equation. Okay, so let's take a look at it. We have the following statement. So to complete the square for the expression of x squared plus bx, we have to add b over 2 squared in order for us to complete that. Okay, and consequently, the formula would be x squared plus bx plus b over 2 squared is equal to x plus b squared over squared, right? So essentially, that is a full square here. And okay, what would be an example of such? So I'm going to give next example. I think the last example was 2. So the upcoming example is going to be example 3. And let's think about the following problem. So we're going to have x squared plus 2x minus 6 is equal to 0. Right, so the left-hand side is not factorable yet, quite yet. So, well, let's go ahead and first move 6 to the right. So let's add it to both sides. So we'll have x squared plus 2x is equal to 6. And now we want to complete the square. So let's think, x squared plus 2x plus what number can give us a full square? That would be 1. Okay, So let's think about it. So if we add 1 to both sides, just 1, right, just 1, we're going to have x squared plus 2x plus 1 is equal to 6 plus 1. So whatever we did on the left side, we have to do on the right side. But notice that now x squared plus 2x is the same thing as x plus 1 squared. And that's equal to 6 plus 1, that is 7. And now from the previous problem, we know that those kind of equations have two solutions, right? It's either going to be so x plus 1 is equal to square root of 7, or x plus 1 is equal to negative square root of 7. So we will have two solutions. First solution, so we're going to go ahead and subtract 1 from both sides, and we're going to subtract 1 from both sides over here as well. So x1 is going to be square root of 7 minus 1, or x2 is going to be negative 1 minus square root of 7. Either of the equations are the solutions to equation 2.3. Okay, perfect. But that also makes us think, well, can we actually use this methodic to find a general equation for a quadratic equation? The answer would be yes. So let's think about the following. We're going to call this a quadratic equation. So in a quadratic equation, let's take a look at the general case. So ax squared plus bx plus c, where we're assuming that neither a is not equal to 0 here. So that's equal to 0, and we're assuming that a is not equal to 0. Okay, so the next step is going to be, let's go ahead and subtract c from both sides. Okay, and so we have ax squared plus bx is equal to negative c. Okay, and now I'm going to go ahead and divide both equations by a, so both sides of the equations, the left-hand side and the right-hand side, so divided by a. So that means what I'm doing is I'm dividing each term by a. So we're going to have ax squared plus x is equal to negative c. So if I simplify the fraction above, I'm going to have ax squared divided by a, bx divided by a, negative c divided by a. Okay, so clearly a and a here becomes 1. Okay? So I have x squared plus b over a, which is going to be a new coefficient. X is equal to negative c over a. Okay, so by using the formula that we just talked about, we can go ahead and add to both sides the b over 2a, right? 1/2 times ba. So x squared plus bax plus, I'm going to say, okay, it's going to be 1/2, right? 1/2. So, but if 1/2 times b, so 1 times b, it's b over 2 times a, that's 2a squared, right? And that's going to be equal to, negative c over a plus b over 2a squared. Now, we know that the left-hand side becomes a full square. So let's actually write it down. We're going to have x plus b over 2a squared is equal to, so here, let's go ahead and simplify. So we have the following: negative c over a plus b squared over 4a squared. Okay, so now what are we missing here? We're missing 4 and 4, so we can rewrite it as 4, so negative 4c over 4a plus b squared over 4a squared, and we have to also multiply it by a, so that's going to be a squared, a times c, right? That's going to be our equation. So here we're going to have negative 4ac plus b squared over common factor of 4a squared. Okay, and now we're going to rewrite it as b squared minus 4ac over 4a squared. Perfect. Okay, so that's what we have. We have b squared minus 4ac over 4a squared. Okay, and now what are we going to do here? We're going to take a square root, right? That's essentially what we do. We know that this equation has two roots. It's going to be one root. One of the roots is going to be just a positive square root, and the other one is negative. So what we will have? We will have x plus b over 2a is equal to, so the way I'm going to do it, I'm just going to write plus or minus square root of b squared minus 4ac over 4a squared. And so by the rules of the square roots and how we can take it, we can say plus or minus, so in the numerator is going to be square root of b squared minus 4ac divided by square root of 4a squared, that is 2a. And now we're going to just subtract the b over 2a from both sides, right? Minus b over 2a minus b over 2a. So we will have that our x 1 and 2 is actually equal to negative b over 2a plus or minus square root of b squared minus 4ac over 2a. So we have a common denominator already, so the quadratic formula is negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so this is a quadratic formula for both of the roots. And one of the important things to keep in mind is the definition, so of how many roots can we have and what kind of roots we will have in a quadratic equation. That comes from the square root. And the square root, we call it a d, which is a square root of b squared minus 4ac, and it's called a discriminant, right? Discriminant. Okay, and that discriminant is symbolizes what kind of equation we will have. So if d is greater than 0, we have two real solutions. If d is equal to 0, we have one real solution. And if d is less than 0, we have two complex solutions, because we're going to be taking a square root of a negative number. Okay, and now, so we are capable of solving any kind of equations. So for quadratic equation. And let's go ahead and write down the summary for it. So here we will have that the solutions of a quadratic equation in general form of ax squared plus bx plus c equal to 0, where a is not equal to 0, are given by the quadratic formula that we just derived, which is x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, and now, once again, let me summarize what I've just said about discriminant. So the equation, the classification of the equations comes in three ways. So very important way to keep in mind is as follows. So the solution to the quadratic equation can be classified. So if discriminant b squared minus 4ac is positive, which is greater than 0, we have two solutions, right? Distinct real solutions, which are not equal to each other. If discriminant is 0, then the quadratic equation has one repeated solutions, right? So repeat solutions means it repeats itself, so that's why there's only one solution. And if the discriminant is negative, then quadratic equation has no real solutions. And it has no intercepts on a real axis, but it does have solution in a complex sense, which we will be talking about later. Okay, perfect. So here we can have a following problem, right? How can we actually use this quadratic equations to do mathematical modeling? So for mathematical modeling, we can think of a following problem. A rectangular sunroom is 3 feet longer than its width. You can see the figure below, and has an area of 154 square feet. Find the dimensions of the room. So area, right? Let's talk about area for a little bit. So area is essentially the zone which is covered by, let's say, length and width. And after this problem, I will a little bit talk about it. But essentially, for a rectangle, we're going to multiply the length of it, which is w plus 3 in this case, times the width, which is just w. And that's going to be the area, right? And I'm going to write it down. So area is equal to width times length. All right, perfect. So now let's think. We want to find the dimensions of this room. So how can we do that? Well, we are going to be trying to solve the equation. Okay? So we know that the width times length is equivalent to the area. And we know that the area of the room is 154 square feet. So, solution. We're going to have that area is equal to width times length. So in our case, width is equal to w, and length is equal to width plus 3. So we're going to have that area, which is 154, is equal to width times width plus 3. Okay. So now let's go ahead and distribute. So we're going to have width squared plus 3 width is equal to 154. And now let's go ahead and subtract. And subtract 154 from both sides to bring the equation into the standard form. So we're going to have w squared plus 3w minus 154 is equal to 0. Let's go ahead and try to factor it out. So we have something plus something is equal to 3, but something times something is negative 154. So we know that 11 times 11 is 121. So if we do, let's say, 14 and negative 11. 14 plus negative 11, that's 3. 14 times negative 11 is 154. So we're going to have that w plus 14 times w minus 11 is equal to 0. So we have two solutions. Either w is equal to 14, right? Negative 14. Or w is equal to positive 11. So which one do you think is the solution? And here we always think of an actual physical solution. Can we have a negative 14 feet of length? No, we cannot, right? So that means 11 is our actual answer here. So 11 is correct. Negative 14 cannot be physically a good solution, right? In mathematics, it's true. Physically, cannot be. So we know that the width is equal to 11, but the length is equal to width plus 3, which is equal to 11 plus 3, which is going to be equal to 14 feet. Perfect. So we were able to find the length and the width. Okay, and then we can have one more interesting, a few more interesting examples. So let's take a look at some areas, right? We'll discuss some formulas for areas. And the first formulas, we already know it's the rectangle, right? Rectangular areas. So here it's going to be common formulas for areas and for perimeters. So a perimeter of a square, right? So here we will have the following. For a square, we have an area, we have the side length of s, so the area is going to be s squared. The perimeter is going to be 4s, because a perimeter is the sum of all sides. So in this case, we simply have s plus s plus s plus s, and since we're all the same, it's just going to be 4s. For rectangles, a little different. It's a more general shape of a square, but now length and width are not equal, so it's going to be length times width. And the perimeter is going to be two lengths, because this is our length and this is our width. We're going to have two lengths, so it's going to be 2 times L plus 2 times W. A circle, so an area of a circle is pi r squared. A circumference, which is the length of the entire circle, is 2 pi r. A triangle, we will have B, which is the base, length of the base times height, which is h, which is perpendicular. And the perimeter is going to be a plus b plus c. A cube, we're going to have, so cube has the same sides, so it's going to be same thing as s times s times s. By the rules of powers, is going to be s cubed. But a cuboid, right, this is a cuboid in this case, and we will have length times width times height, right? All of the numbers are different, so we're just multiplying them together, and we cannot simplify the same way we did at the cube. And then circular cylinder is going to be the circle, right, times the height that we extended it to. So essentially, we're just laying out the circles to a certain height. And then a sphere is going to be 4/4 pi r cubed. Okay, perfect. So these are some formulas for the areas of different shapes. And in addition to that, we can also have a few more equations related to other kinds of equations. So the equation that we haven't yet discussed is the circle, right? And let's take a look at how the circle equation actually looks like. So a point, right, lies on a circle of a certain radius, right, and it's a certain center in the following form, right? So we have a point x comma y, and it's on the circle, right, of a radius r and a center h comma k, if and only if we have the following equation, right? And let's graphically demonstrate that. So here would be a demonstration of the circle, right? We have an x and y axis. We have a center, which is h comma k, right? And that's how we scale it up to the center. And r is the radius from the center to the furthest points of the graph. So if we're going to say, well, if we are radius at the center of the axis, right here is the center of the axis, which is 0, 0. So if h comma k is equal to 0 comma 0, then we're going to have our equation become so x squared plus y squared is equal to r squared, right? Which is the most famous equation for the circle. And then what we can say is we can have one of the equations, right? One of the problems here. So let's solve this problem of finding a circle. So it's going to be example 3.1. And it's going to be the point 3, 4 lies on a circle whose center is at -1, 2. And let's go ahead and actually show the picture, the figure 1.7. So this is a problem from the book. And here is the equation, right? So we want to write a standard form of the equation of the circle, right? So we're given that the center is -1, 2, and then the first point is 3, 4. So what we want to do is, well, we want to remember that if we solve for r, is going to be square root of x minus h squared plus y minus k squared, right? And so we are given our h comma k and our other point, which lies on the circle. So we're going to have that r is equal to square root of 3 minus -1 squared plus 4 minus 2 squared. Okay, we got to remember to preserve the negative sign. So r is equal to square root of, so we're going to have 3 plus 1, which is 4 squared, plus 4 minus 2, which is 2 squared. And that's equal to, so 16 plus 4 is equal to square root of 20. Okay, so that is our radius, right? Radius of the circle. So this line right here, square root of 20. Okay, and then now we will have to write down the equation, right? So by using the definition that we just learned, we're going to have x minus -1 squared plus y minus 2 squared is equal to square root of 20 squared. So the final equation is x plus 1 squared plus y minus 2 squared is equal to 20. All right, that would be the standard form. Right? Perfect. That would be it for this lesson. Thank you and see you in the next lesson.